Q7026. If the wing moves behind the pylon during properly coordinated Eights-on-Pylons, the airplane is A. Flying too fast. B. Below pivotal altitude. C. Above pivotal altitude. The correct answer is C. Eights-on-Pylons is a maneuver where an aircraft performs coordinated figure-eight patterns around two pylons located on the ground. The question states that the wing moves behind the pylon, and we need to determine the meaning of this situation. During the maneuver, the pivotal altitude plays a crucial role. The pivotal altitude is the altitude at which the aircraft's ground speed is minimum while maintaining a constant radius turn around the pylon. It is the altitude where the aircraft achieves the most efficient turn. When the wing moves behind the pylon, it means that the aircraft is flying a higher path compared to the desired pivotal altitude. In other words, the aircraft is above the pivotal altitude. Being above the pivotal altitude has specific implications for the maneuver. It typically results in a larger turn radius and a slower ground speed than intended. The decreased ground speed leads to the wing appearing behind the pylon from the pilot's perspective. To correct this situation and align the wing properly with the pylon, the pilot needs to ascend to the pivotal altitude. Ascending to the pivotal altitude ensures that the aircraft achieves the desired ground speed and turn radius for a properly coordinated Eights-on-Pylons maneuver. 6316-1. Which is the correct symbol for the minimum steady flight speed at which an airplane is controllable? A. Vs. B. Vs1. C. Vs0. The correct answer is A. In aviation, the term stall speed refers to the minimum speed at which an aircraft can maintain controlled flight. It is the speed at which the wing's critical angle of attack is exceeded, causing a loss of lift and a stall condition. The symbol used to represent the stall speed of an aircraft is Vs. The V stands for velocity, and the S stands for the term stall. Therefore, Vs represents the minimum steady flight speed at which the airplane is controllable just before it reaches the stall speed. 7036. Which is a correct spin recovery technique? A. Apply forward elevator control followed by aileron opposite the spin. B. Apply full forward elevator control followed by a coordinated rollout. C. Reduce power to idle. Apply opposite rudder and forward elevator control. The correct answer is C. When an aircraft enters a spin, it is in an aggravated stall condition with one wing more deeply stalled than the other. To recover from a spin, specific actions need to be taken to regain control and stop the spinning motion. Here's a breakdown of the steps involved. Reduce power to idle. By reducing the power to idle, the aircraft's engine thrust is minimized, which helps in reducing the spinning tendency and overall aerodynamic forces contributing to the spin. Apply opposite rudder. Applying opposite rudder means using the rudder control to counteract the yawing motion of the spin. For example, if the aircraft is spinning to the left, applying right rudder will help counteract the spin and stabilize the aircraft. Apply forward elevator control. Applying forward elevator control involves pushing the control column or yoke forward to break the stall condition and reduce the angle of attack. This helps in recovering from the stall and allows the wings to regain lift. By following these steps, the airflow over the wings can be restored, and the aircraft's rotation can be stopped. Once the rotation stops, the pilot can then smoothly and coordinately roll out of the spin by applying appropriate aileron input to level the wings. 7225. Which stall must be performed during a flight instructor airplane practical test? A. Power on or power off. B. Accelerated. C. Imminent. The correct answer is A. Stalls are an important aspect of flight training and are typically evaluated during practical tests, including the flight instructor airplane practical test. Stalls are maneuvers where the critical angle of attack is exceeded, resulting in a temporary loss of lift and an aircraft's nose dropping or pitching uncontrollably. Power on stall A power-on stall is performed with the engine at a high power setting, simulating a takeoff or a go-around scenario. The purpose of this stall is to assess the pilot's ability to recognize and recover from a stall while experiencing the effects of high power. Power-off stall. A power-off stall, also known as an approach-to-landing stall or landing configuration stall, is performed with reduced power or at idle, simulating a landing or approach scenario. The purpose of this stall is to evaluate the pilot's ability to recognize and recover from a stall while in the landing configuration. Both power-on and power-off stalls are critical maneuvers that test a pilot's knowledge, skill, and proficiency in recognizing and recovering from stalls in different flight conditions. These stalls are typically evaluated to assess the pilot's ability to recognize the stall warning signs, take appropriate recovery actions, and maintain control of the aircraft throughout the maneuver. 7029. The objective of a cross-control stall demonstration is to A. Emphasize the hazard of an excessive slip during a landing approach. B. Teach the proper recovery technique should this type of stall occur during final approach. C. Show the effect of improper control technique and emphasize the importance of coordinated control when making turns. The correct answer is C. A cross-control stall occurs when the aircraft is in a stalled condition while the ailerons and rudder are applied in conflicting directions. This situation often arises when a pilot applies excessive rudder input opposite to the direction of the bank during a turn. Effect of improper control technique. A cross-control stall demonstration showcases the consequences of applying improper control inputs during turns. By deliberately inducing a cross-control situation, the demonstration highlights the adverse effects it has on the aircraft's stability and control. Importance of coordinated control. The demonstration emphasizes the importance of coordinated control inputs when making turns. Coordinated control means applying appropriate rudder input in conjunction with aileron input to maintain proper coordination and prevent adverse yaw. By showcasing the cross-control stall, pilots are reminded of the need for coordinated control to maintain safe and efficient flight. By demonstrating the cross-control stall, instructors can illustrate the risks associated with improper control technique, including the potential for adverse yaw, loss of control, and increased stall/spin susceptibility. This serves as a valuable lesson in the significance of coordinated control inputs, especially during turns, to maintain safe and controlled flight.